We are doing the reaction part of the alcohol. The first topic that we are doing today is dehydration of alcohols. And over here I have taken tertiary butanol, okay, which is also abbreviated as this way. So out here I will use H2SO4, that too concentrated, because concentrated H2SO4 is a drying agent or a dehydrating agent. So basically out here my product will be isobutylene. This will be my product with the release of water. Okay. What is the mechanism for the reaction? So out here one has to think that whenever an acid is given and there is a OH group, as I have told you before, that protonation of the OH will take place. What happens when OH group gets protonated? It becomes from a bad leaving group to a good leaving group. In the next part of the reaction, OH2 will be released, this bond will be broken, and it will result in the formation of a carbocation. Okay. So this is my rate determining step, that is the formation of the carbocation. And this is a 3-degree carbocation. So here we have a CH2H unit which will undergo elimination of the H. So here we are undergoing elimination of OH, here we are undergoing elimination of H, and that leads to the formation of the pi bond, and this is the fast step. So this type of pathway in which a carbocation is formed, okay, and via elimination of two such groups, that is a H and a OH, a double bond is formed. So it is basically you're taking away groups, elimination. So we will call this as E1 mechanism. E1 mechanism, always carbocation is formed. Okay. Now let us do some examples to understand what kind of products will be formed when this type of alcohols given in the example undergo elimination. So I have used H2SO4 again. Elimination is always done in heating conditions. Substitution is always done in low temperature conditions or room temperature conditions. So here we will have this type of protonation. Okay. This will go away. And we will be thinking that this type of a carbocation will be formed wherein with respect to this particular carbon there is a CH2H here and there are also H here. So either this H or that H can go, leading to the formation of a double bond. But what will be the major product? So let's draw the products and then think. So if a exocyclic double bond is formed, which means what? Double bond is lying outside the ring. We see this is least substituted double bond in comparison to the one that I am drawing below. This is the most substituted double bond. So this is my ZJ product, and this is my Hoffman product. And whenever we are forming products of alkenes via dehydration of alcohols, my ZJ product is the major product. So this will be the major product. And this is my minor product. Okay. Some points, quick points about dehydration. Okay. Remember, redetermining step is the carbocation formation. That means 3-degree carbocation is formed faster than 2-degree, then 1-degree carbocation. Which means 3-degree alls react faster or dehydrate faster than 2-degree all, then 1-degree all in a E1 elimination reaction. Since carbocation is formed rearrangement can take place. So if there is a 2-degree carbocation, it will rearrange to a 3-degree. Such possibilities are there. Quickly, one should understand, if you take the same alcohol, I mean tertiary butanol, sorry, and now if you tosylate it, that is you treat with TSCl in presence of pyridine to take care of the HCl that will be produced, because your compound out here is what? OTS is formed. Now, if you treat this one with sodium ethoxide, or as it is sometimes written in your book, hot ethanolic KOH, or if you use sodium ethoxide. Now, mechanistically it will change. No carbocation can be formed, but elimination will be in one step where this base will take up the proton. Okay, and that will be acting as the leaving group. One step mechanism is operating, so this is basically having a base and a molecule. So this is E2 mechanism. No carbocation formation is possible here. But again, you are getting the same product. Mechanistically, the reactions are different. Okay. What is actually happening when OH is getting tosylated from bad leaving group? You have generated a good leaving group. That is all we have done. So let us do another example in which suppose we have been given this alcohol and we treat it with TSCl in presence of pyridine. Py means pyridine. What is the product we expect? to be formed over here. OTS. In respect to this carbon, now if you treat it with a base like sodium ethoxide, this base will look for acidic proton. So if this is the alpha, that is the beta carbon, and this particular proton, it will abstract. So if this takes up that proton, then that comes in here and that will be released. So we are going to get basically cyclopentene. Again via E2 pathway. Okay. What other methods can we use for dehydration of alcohol? So we are doing basically here again dehydration of alcohol using copper. What is the temperature? You can also use silver. Okay. 573 Kelvin. This is what one has to remember as a student of class 12. 1 degree alcohol, there is hydrogen. You take away hydrogen from OH and from one carbon next to it. We get aldehyde. 2 degree alcohols, you take away hydrogen, you make a ketone. Again, the same analogy that we used while we were oxidizing alcohols using PCC, PDC. But when you come to the case of 3 degree alcohol, there is no formation of aldehyde or ketone, but out here a alkene will be formed. That is what one has to remember about this reaction, and this reaction comes. Now, to summarize all facts in the things that we have done in the previous classes, and the things we did today. Suppose you have been given one pentanol, okay, and I am taking out arrows, putting some reagents over here. Okay. These are good for final preparations, when you go for final touches in a subject or final touches of a chapter in a subject. This kind of scheme based reactions, they help you to collect whatever you have studied for quick preparation. Okay, mind you. Okay. So what I would want is you to guess the products, and only if you read this and go in an examination hall, then also your preparation will be complete. If you do not want to go through the entire notes that has been given to you, just knowing which reagent does what. So if I say this is A, what will you say about the product? Just give it a try. Shabir.
স্যার ব্রোমিনটা স্যার যুক্ত হয়ে যাবে, ওএইচটা চলে যাবে।
Right. In the next one, so this is butanol, right? Yeah.
Yes, sir.
This is N-butanol. Sorry, one correction over there. Next.
Sir, next the product will be chlorobutane.
Next one.
Sir, same product, sir.
Yeah, that is Grove's reaction, right? Next one.
Yes. Sir, next, sir, the elimination, sir.
Yeah, but here major will be this one followed by a few more other. So these are your likely possibilities, but this is the major.
Yes.
Next one. Lithium alkoxide, right?
Yes, sir.
And hydrogen will be formed. Next one.
Sir, ONA, sir.
Yeah, so it is basically hydrogen and the alkoxide, right? But
Yes, sir.
here 1 mole of hydrogen is formed and here half mole. Next one. Same thing.
Same product, sir. Yes, sir. But hydrogen is not. Have hydrogen.
Half hydrogen, right? Very good. Next one.
Sir, it is a JMS.
TMS. OTMS. Other one.
Yes, sir.
PCC.
Sir, LDS, sir.
Right, very good.
Voice is common.
Next one. Jones reagent क्या होगा?
The same, sir. LDS.
Hmm?
The voice is converting.
1 degree alkyne na? 1 degree alcohol na? So it will be the acid.
Oh,
So one mistake you did out of that.
yes, sir.
Others are correct for you. Now, you have to predict the reagents out here, okay? Predict the reagents. Just the reverse to prepare these compounds. So I have given you over here again the same thing. And I'm asking you, give me the reagents. Alright?
Yes, sir.
Yeah, try. N-butanol to butanol. Butanal, right?
Sir, PCC, sir.
Okay. So it can be PCC over here, or you can use PDC, right?
PCC.
Or you can use lead tetraacetate. Okay, anything you can use. This one, next one,
Sir, Jones reagent.
Jones reagent. Now, what about this one? See, you have an extra group like this. Okay. Whenever you get these kind of problems, okay, you have been given one starting material, they are asking how to make this compound. So you try to follow this that I'm showing you. This is a retrosynthetic arrow. You break this bond and make a double bond, and this bond subsequently you break at the same time. So what you are getting, right? This one,
Yes, sir.
and over here you are getting basically it is CH2 minus CH3. Okay, these are called synthons. These are not a part of your syllabus, but you should know all this. Now this one you will convert immediately into as CH3 CH2 MgBr. Understood? Now if you think you react this one with this one, you will get this product. Follow?
Yes, sir.
Okay. Again, you have been given this one. Okay.
Yes,
You
sir.
are having this one. So what to do? Convert this into alcohol. Okay. Ketone is there, you convert this into alcohol. Now you practice what I have said. Like this, you go back and then you can do this. Right?
Yes, sir.
So basically you are having what? Starting materials. This is one of them. And it is going to be CH2, CH2, CH3, right? And you convert it into what? CH3, CH2, CH2, MgBr. Now if you react this one with that one, you will get this alcohol which you can oxidize by PCC to get that one, right?
Yes, sir.
Okay. Similarly, you try this one, okay? That is what I
Yes, sir.
wanted to say. Okay. In the next one, we are doing a multi-step reaction, okay? Suppose you have this, sorry, aldehyde, and they are saying use some reagent A, and you convert this into this type of alcohol. So this is your CH3. Then they are saying use some reagent B, convert this thing into the ketone. Now use some reagent C. So this is a full combination of like reactions that will help you to master topics like Grignard reagent and whatever things you have learned in alcohol. Okay, even your dehydrations reactions. So this is what we have. Okay. And then again you react it with D. Alright. And the alkene you will have over here is going to be this one. Alright.
Yes, sir.
From this one we are reacting with again E and we will have this type of an alcohol. Treat this with some reagent F and you are getting. Okay. And then again from here you are getting this one. Okay. And then if you use H, you will get. So I'm just giving you one such example. So you tell me now what will you do? What will be
Sir, A.
A? Hmm.
Sir, A is sir CH3 MgBr.
Okay, very good. Obviously followed by acidic workup. Yeah.
Yes, sir, acidic one.
In the next one,
Sir Jones.
yeah, you can use Jones also. Second degree alcohol. Na? Jones or PCC, whatever you want to think of. Next one.
Sir pH MgBr plus
Very
acidic
good.
metal.
Yeah. Next one.
Sir sulfuric acid plus H.
Yeah. So concentrated H2SO4 and heat. Next.
Sir HBO.
Right. Hydroboration reaction. Next.
Sir PBr3.
Hmm. Next. Yes. In this you have to do Mg ether and then you have to follow it up by CH2OH. Sorry, CH2O. That is formaldehyde. Then you do the acidic workup. Next. अल्कोहल है एल्डिहाइड पे जा रहा है बोलो
Sir PCC PDC
या
or
PCC PDC stick with that only. So we have completed this part. There are three tests for alcohols and try to get it from your book. Jones reagent I've already discussed. Okay. There is something called Lucas test. No aqueous medium or anything is used over here. Just you take the alcohol. This is 2 degree alcohol, 1 degree alcohol, or you have a 3 degree alcohol. Okay. Basically, you should get some turbidity. Okay. For a 1 degree, no reaction at RT. That means room temperature. Here you will get some white turbidity because of formation of your alkyl halide. Okay. Basically, here we are adding what? Anhydrous ZnCl2 to the alcohol. Okay, and this test for turbidity will come after 5 to 10 minutes. But here turbidity happens immediately. This is one of the tests. Another test is called Mir test. I'm just giving you the qualitative idea. You can read the textbook for further detail. If it is your 1 degree alcohol, okay, out here you will get red color. So I'm just going to for this only. Okay, color क्या होगा? If you have 2 degree alcohol, it will be blue color. Sometimes only color is asked. Okay. If you have 3 degree alcohol, no reaction. Okay. This is what it is. Now, some reactions on diols. Okay. So we are doing a reaction of dihydric alcohols. So again, I have given you ethane 1,2-diol in the center, and I am asking you similar questions that I have asked before. Sodium, PCl5 individually. Now you are adding these reagents to monohydric alcohols. Now you are adding to dihydric alcohols. We have PBr3. Okay. If I give you PI3, PI3 is not very stable. I need to use phosphorus with I2 basically. HCl 100 degrees centigrade. Okay. Say I have given you acetic anhydride. Alright. I have given you, this reaction will be new for you, concentrated HCl3. I am giving you KMnO4 heat, okay? I have given you HiO4, alright? I have given you PbAsCO4, tetraacetate, okay? I have given you cyclohexanone in presence of dry HCl. Alright. Okay. So these are the things that I have given you. Now use your previous knowledge to tell me what can be happening out here. Good. OH and OH. Okay. So what will happen?
So which is converted into ONA.
Right. PCl5?
Sir, yes, sir, Cl. So which
Okay,
is
very good.
substituted by the OH, Cl.
Yeah. Next.
So the OH is substituted by the bromine.
Right. Next.
Sir, iodine, sir. OH is
Yeah,
substituted.
but these type of iodines, they are not stable enough. So
Yes,
elimination
sir.
will take place. Yeah, I2 will go away and it will form H like this. This one, I'm helping you out. This also will give ClCl.
Yes,
Acetic
sir.
anhydride and OH, basically esterification will take place and it will form OAC. OAC is what? AC is COCH3. I have told you before. Okay. Now this concentrated HNO3, as I said, this will oxidize, always oxidize CH2OH groups. Okay. So basically out here it will be oxalic acid, that is the compound that will be formed. Any idea what will happen when you use KMNO4 with heat?
Yes, sir. Oxalic acid.
No, formic acid.
Yes, sir. The formula is ACOH.
Yeah. What will happen when I use HiO4? Oxidative?
Sir, sir, ACOH
Yeah, oxidative cleavage. Similarly,
plus ACH.
yeah, oxidative cleavage. Again, same thing. PbACO4 and HiO4 will do oxidative cleavage, right?
Yes, sir.
This we have covered before. So, wherever you're not able to answer properly, you just remember that you have to revisit it and learn. What happens over here when you use a ketone and this 1,2-diol? Any idea?
Sir, I have no. No, sir. I have no idea about.
Acetal formation. Here it will be ketone, right? We have done
Yes,
this,
sir.
right? Yeah. Okay. Fine. Now, again, synthesis and reaction of, this will be our last topic today. Preparation of trihydric alcohols. Okay. And this is where we will end. And next day we will take up ether. Okay.
Yes, sir.
So suppose we have this compound, propene. You treat it with CH2 in CCl4. You know over here addition will take place in anti manner. This is
Yes,
anti-addition.
sir.
Okay. And if you use NaOH dilute, alright? If you
Yes,
use
sir.
NaOH dilute, one of the Cl will be replaced by OH and elimination will take place. So elimination and substitution are taking place at the same time. Okay, this is CH3, alright? Now to this particular alcohol, what can you do? You again add a HOCl. Sorry. What will happen? OH will add here and Cl will add here. Obviously Markovnikov addition, right?
Yes, sir.
If you use again NaOH aqueous further, that gives you the glycerol, or also known as trihydric alcohol. Okay? Glycerol or
Yes, sir.
trihydric alcohol. Suppose we have been taking this one. This is called acrolein. You try to reduce this with NaBH4. Double bond will not be affected, but the aldehyde group will be reduced. Now you know if you use H2O2 or if you use even MCPBA followed by aqueous acidic workup or alkaline workup, whatever you do, your product will be, this will lead to the formation of a epoxide, okay? Form a epoxide like this, alright, after double bond removal. So basically again we are getting this type of alcohol. So these are called trihydric alcohols, okay? Or glycerol. So we are doing glycerol synthesis. So what I will do is I will make a chart, okay, again for you, and you try to answer what can be the products. So out here I am starting again with Na. I have again used a PCl5. Again I am using PBr3. Alright. I have used P with in the presence of I2. Okay. And I have used over here, say, HNO3. Okay. Actually, this forms dynamite. Okay. So try to find out what is the formula of dynamite. That is your trinitroglycerin, TNG. Okay. Understood? Okay. So for this one, so these reactions you try to find out. Okay. So I am leaving you today here. Let's end the discussion and we will take forward in the next class the ether part. Okay. And we will be covering Williamson synthesis of ethers and preparation of some aryl ethers. And in that section only, I will discuss the other section which I was saying, like elimination and substitution versus that part. We will take up. Okay. Thank you for listening. Have a great day.